Students, I have Tenenbaum, third edition, a modern operating system. Okay, PDF of that book I have. I will share with you. Okay. But I remind you again, for operating system, it is the good way is when I'm taking the lecture, you have to take notes, short notes. Okay. So that will be helpful lot when you study for the semester exam. Okay. Students, every time, even half of the students only attending the lecture. I don't know what happened to others. Now see, only 62 students are there. Your strength is 119, right? And one more thing. Okay, sorry. Yes. The first year, no. I'm going for all the classes, no? FY, SY, TY, MSc, and also I thought your SY. Okay. Even this FY strength is now 119, right? So as per that, your attendance is very low comparing with your strength of the class. And students, yesterday night, I just added the batch 2 students for practical. Okay. So I think I did some mistake. Okay, wrongly I added the batch 1 student, something like that. But batch 1, I think today you have practicals, right? Batch 1. Uh, so all the roll number 1 to 65, you know your roll number, no? So roll number 1 to 65 will be in batch 1. Okay, we added like that only. So from roll number 1 to 65, if anybody is not added in the batch 1, then please let me know, because before I have to add. I think batch 1 added properly. Batch 2 only I have to I have to verify, I have to check. Okay. So if anybody is not added, batch 1 student not added in batch 1 team, please let me know, because that should be done today. Batch 2, we can see we have time. So by today night, I will do, I will recheck. Okay. But from roll
Ma'am,
number 1 to 65 must be added in batch 1. Then only you can attend today's practical. Yes, Glory.
but today batch 1 has NSM practicals.
Batch 1, no.
OS is for batch 2 practicals.
No, OS I will not start today.
Okay.
Yes, OS practical you don't have today. Okay.
Okay.
OS practical is not there because usually practicals, no, after we start 2 weeks later, starting the theory only we will start. Okay. So 2 weeks we will complete theory, and then we will start the practical. Biju ma'am is having only practical, I think. That's why she's starting. Okay. So OS practical is not today. Before starting, I will tell you. Okay. I will inform you priorly. I'm going to start the practical so and so date onwards. Okay, that I will inform you. Okay, but today you don't have practical. But you have Biju ma'am's practical. NSM practical you will have. Okay. Batch 1 will have NSM practical. Ma'am said she's going to start the practical today. That's why yesterday we created the separate teams. Okay. Operating system practical will not be there today. I have to share the book with you. Okay, remind me. That's what I said. No, that book is very vast, but of course, I am referring that book only, as that is a reference book for your subject. I am referring that book only. Okay, operating system by Tenenbaum, modern operating system by Tenenbaum, third or fourth edition. You can follow. I have the PDF of third edition. I will share that with you. I'm following that only, but we are not going to cover. If every topic, it's very vast. So we are not going to cover everything in each and every topic. Okay. So whichever is important, that only we can cover. If you see the book, PDF of book, you will come to know. So that I'm saying, even in the same book, if you have to study, you have to know what are the points I mentioned in the lecture. Okay. Then only when you go through the book, okay, you will know that which are the points you have to cover, you have to study. Okay. Each and everything is very vast in that book. Okay. So I'm following that book, but you have to take notes simultaneously. Take short notes. That practice you have to have. Came to college, you must have started before itself, but if not, please start now. All the subject. Programming and all, when you are performing, of course you will have the file. Okay, you no need to do that. You can only concentrate on typing the program, executing it, getting output and all. Okay, but when I'm teaching theory, some of the theory subject direct book will be there. Okay, so in that case also, it's not required you have to take the lecture notes simultaneously when teacher is teaching. Okay, but operating system kind of subject is, it's theory, but it is very challenging, very concept, deep concept oriented subject. Okay, so you should able to compare when I'm talking about program counter, what we discussed priorly in some other lecture about the program counter and all. Okay, so all the concepts are interlinked, but it will not be used at a time in one chapter. Okay, in all the chapter, here and there we will use. So you have to remember what we studied about that particular topic in previous lecture. Okay, so that's very important. So take notes. Okay, again and again I'm repeating, if you're not serious, then you will be the loser. Remember. Okay. If any doubt, you can ask during the lecture. And if I explain very fastly, you may say to go slow, and you may ask me to repeat any points if you couldn't note down. Okay. If you want to note down, you can tell me to repeat. Okay. So that you have to do. Okay. Now 77 students are there. Okay. Okay, one more thing, students, February 12th, we are conducting a PTM, Parents Teachers Meeting. Okay, in that we will show, of course, we will discuss about your classroom performance as much as possible, because direct class we did not take. So, as teachers, we are also not knowing much about each and every one of you individually. But we will, whatever we know, we observed, we will discuss with your parents. And this is especially to show your attendance to your parents, because your parents should know whether attentively or attending the lecture. Of course, attendance will not say whether attentively or attending the lecture or not. It will say whether you attended, what is your percentage of attendance in semester one. Okay, so subject wise, till now from our end it did not go to office. Okay, because um, this absentees practical we conducted now only, last week only, right? So so it will take some time. But we are very, the examination committee is very keen to publish the result very soon. Okay, so mostly within 2 weeks you will get. Okay, but actually today we are taking the printout. We entered everything, but we are taking the printout, and today we are submitting. Actually, I have to go to college and submit. Okay, after submitted immediately, if no issue, they will release the result. Okay, but at least for processing, it will take at least 1 week. Okay. Okay. No. The only odd semester we will keep. Okay, but don't take this as advantage. Okay, default as list will be put up. Okay. Uh, so attendance, you know, at whether attendance is important or not. Okay, just because of conducting PTM, you should not keep the attendance as high, or otherwise you no need to attend the lecture. It's any okay. So you know that you all are grown up. I no need to say that. Ah, uh,
Soft copy or a hard copy of the result will be provided in 2 weeks.
mm, in website, the soft copy will be put up. You will see, and then the hard copy will be given.
Okay,
But
ma'am.
giving the hard copy will take some time. Okay, so office will prepare the mark sheet, and then they have to fix day to distribute the mark sheet for all the classes. But they will not keep all the classes department by department, or year by year they will keep. So it will take some time, but releasing the result will happen soon. Okay.
Okay, ma'am. Thank you, ma'am.
Ah. But this semester one result is actually not exactly for your performance, huh? So that you also know, as teachers also know. Okay, because when I compare the internal practicals, especially practical and theory, I feel very bad because practical directly I conduct, no, of course all the teachers. So through your answer or your execution with respect to other subject, that's a direct that is we gave the marks for only your performance. Okay, we did not give extra marks, but internal, because internal had one of the component as class test, you know. So that is also we conducted online. So many of you, it's not a this one, not a reliable one for from us. Students also are studying good, got very less mark. Did not study, got very high mark. Essay and all. Even theory also, semester theory also the same thing. So mostly, but definitely the semester two will be direct physical exam only. Okay, so offline exam only will be there. So you don't think that, you don't be lethargic thinking of the first semester. That is completely different. Semester one is completely different. You know how truly you gave the exam. Okay, I no need to say. So those marks are not very much reliable. Okay, but so if you're thinking of that again, without studying and piling up the studies, then you will suffer now, because now the college is going to reopen. The government is talking about that. Definitely within 1 or 2 weeks. 2 weeks is more, I'm saying, but before that they will start the college. So definitely your semester two exam will be offline. So you have to, starting from first itself, you have to prepare accordingly. Okay. Otherwise, in the last minute, you will be messed up with all the things, because you did not study, you did not keep notes properly. Mm, so at last you can't do anything. Okay. Nobody will help also, because in studies, when you ask help in the beginning, everybody will help. In the last moment, everybody will have assignments and project work, everything. Okay. So it will be, they will also be not there in the position to help you. Okay. And the better one is, you no need to rely, studies rely on anyone. Okay. There are many materials in the net. You have to plan and you have to work. smart. I should not say hard. You have to work smart. Okay, then you can score very good mark. Even the exam is conducted in offline also. Okay, so about this already many times I said. So you have to uh, take care that. Okay, taking the notes for whichever subject required, and whichever subject there is no direct textbook. But here we have a textbook. But the textbook is very vast. That's a problem. Okay, so when you go through, you will not know what to study, what to leave, and all. There are so many things. So at that time, which will be helpful, attentively attended the lecture will be very helpful. And you must have to take the notes also. Okay. Uh, we have to see about the processor. We discussed some points. Okay. I think you remember what is pipelining, three-stage pipelining, superscalar pipelining, CPU cycle. Okay. So all those we discussed during last lecture. Now memory. What do you know about memory? Computer memory. What do you know about computer memory? Mm, mm. Okay. Only RAM and ROM are there.
मैम processors internal memory.
Yes, yes, Supreet. Yes.
इंटरनल मेमोरी मैम प्रोसेसर का जो रहता है अलग से छोटा सा.
Okay. Internal memory. Internal memory means what? You may. When you are saying internal memory, internal to what? Internal to processor or internal
प्रोसेसर मैम प्रोसेसर.
internal to processor. Okay. Anybody else? Other than these points, whatever they said, Supreet and Kaifali, you know anything about the computer memory?
मैम इतना ही पता है मैम जहाँ तक है. टोटल 3 होते हैं, इसके आगे का पता नहीं.
Okay. So you know buffers. Buffer is also type of the memory. Okay. But there, the name itself implies no buffer means temporary. So temporarily we will store the data, buffer the data, and then we will release it. When we will release, if any other new data we have to store, we have to release the previous one, used one. Then we have to store the data again, new data. Okay. So the big second major component in computer is memory. What's the first one? CPU, processor. Okay. So memory is a second important major component in the computer memory. Why it is very important? What is actually required? When I'm saying processor, which is good processor, what you will say? Ma'am, the processor which is working in high speed is a good processor. So speed defines the performance of the processor. Okay. So how the speed will be increased in the processor? Um, it may be depending on many architecture. Maybe the architecture itself, processor architecture itself may support the speed of the processor. For example, there are two types of architecture computer. See, these and all you no need to note. Generally, I'm saying okay. Two types of computer architecture. One is von Neumann architecture, and another one is Harvard architecture. These two are very popular computer processor architecture. Okay. In one processor, we have so many bus lines, and another processor, there is a single bus line. So when more number of bus lines, cables are there, of course, that processor will be the faster processor. So this way, the processor, the architecture of the internal structure of the processor itself may support the speed. Okay, that's one thing. Another one, the processor speed is depending on the timer. That's another device. You might have heard crystal oscillator, clock, and all. So that will also define the speed of the processor. Okay. So including some of the chips, some new chips, fast chip, are making the circuit very short circuit, we can increase the speed. Okay, there are many techniques to increase the speed of the processor. Of course, the preferable processor is always what? The high speed processor. Okay. Now to memory. For memory, what we require, what we expect from the memory. From the processor, we expected that it should be high speed, high in speed. Okay. Like that for memory, as soon as I said memory, you will say memory should be sufficient, big enough. Okay. But it's not true. Okay. Memory, of course, memory should be the first thing, memory should be extremely fast. Extremely fast. Why? Ma'am, you said processor is very fast. That we can agree. But how memory should be fast? Because the processor and memory should always communicate. Okay. So processor is built using a very faster materials, very fast accessing material. So we no need to go in depth. You may ask, ma'am, how the faster material, matlab what exactly it is. We can say if you look at the chip, okay, the architecture of the chip, detail we can say the transistors, number of transistors in a single cell of the chip should be more, will increase the processor speed and all. Okay, but memory we expect fast because memory should compensate when it is working along with the CPU. CPU should not wait more time because the memory is very slow. Memory is very slow, matlab what? If you want to take any data, it should not take more time for the processor. You stored some data in the memory. Whenever you want, easily you should able to pick up. So if quickly if you pick up, then the processor no need to wait till the memory is giving the data. Getting it? I think now you can understand. So in that way, the speed is very important for memory. Okay. So memory should be faster one. Not only that, there are very many requirements. Memory should be extremely fast so that the CPU should not held up by memory unnecessarily. And then we want very large memory space. Memory capacity should be very high. And at the same time, we want the memory in cheap price also. All these we are expecting from with respect to memory. Memory should be very fast, memory should be very large, memory should be very cheap. Okay. But no current technology satisfies all these goals in a single memory. Either speed is high, the storage will be less. If storage is large, speed will be less. If storage is large, it will be cheaper. If it should be the speed is very high, it is very expensive. I say, okay. So nothing is directly proportional. Everything is indirectly proportional. So if one increases, another will automatically go down. So all the three you can't expect from single memory. Okay, this you have to understand first. So there is no new technology invented to give all the three. That means the memory is a single memory that is very fast. It's the space also very high, the capacity also very high. More data we can store. At the same time, it is very cheap also. So no such memory invented till now. Okay. So this is the reason. This is the reason we have, look at the diagram, hierarchy of memories. Okay. Hierarchy of memories. Registers, cache memory, main memory, magnetic disk, magnetic tape nowadays we are not using. So all these different memories. But what is the purpose of all these memory? It is used to store data. That's it. You can store data. Okay, whatever you want to store, you can store within this. So memory is a storage device always. Okay, memory is a storage device. If you look at the top layers, the top layers have higher speed, smaller capacity, but a greater cost. Very high, expensive. Okay, registers, cache, main memory, and all.
Ma'am, can you repeat top layers what?
The top layers, you can assume first two layers or three layers, of course. The first two, three layers, no, the top layers have higher speed. For example, registers is very speeder one. It is inside the CPU. Okay. Some registers are inside the CPU, remember. Okay. Cache is little slower than registers, but it is faster than memory, main memory, magnetic disk, and a magnetic tape. What about main memory? Main memory is faster than the below things, magnetic disk, magnetic tape. It is slower than cache memory and registers. Okay. You can imagine here, you may think where is ROM, read only memory. You can replace the magnetic disk. Generally, they have given the permanent memory as magnetic disk. Okay. There even you can imagine ROM also. Okay. ROM is little faster than the secondary disk drives. Okay. So these are the layers. These layers are arranged as per the, we can say, speed. See, here for registers, access speed is 1 nanosecond. Cache approximately 2 nanosecond. It is the access speed. Okay. Access speed matlab what? If you want to take any data, access, you want to read any data or you want to write any data inside this memory, this is the approximate time which will be taken. That's called the access time. Okay. Main memory 10 nanosecond. Magnetic disk 10 microseconds. This is 100 second. So compare the speed. But you compare the right side. This is very faster, but see the capacity 1 KB. Okay. What is 1 KB? 1 KB is lesser than 1 KB. Lesser than 1 KB is the space of registers. 1 KB is approximately 1000 bytes. You know, 8 bits equal to 1 byte. You know, 8 bits forms 1 byte. Okay. So like that, 1000 bytes. Okay. 1 byte may 8 bits are there, remember. So it is less than 1000 bytes. Okay. And MB, 4 MB, that means 1 MB equal to 1000 kilobytes. 1000 kilobytes equal to 1 MB. Then you can imagine 4 MB. Okay. These are approximate. Okay. And main memory 512 to 2048 MB. Okay. Magnetic disk, this is gigabytes. Okay. So this is very large memory. Of course, terabytes also there. Nowadays, external hard disk and all there in terabytes and internal hard disk also. But 1 gigabyte equal to 1000 megabytes. 1 gigabyte equal to 1000 megabytes. You know what is megabytes? 1 megabytes में 1000 kilobytes are there. 1 kilobyte में 1000 bytes are there. You know that. Okay, so now you can compare the speed and size. But here the cost they did not mention. But the very faster memory is which one? This. Depending on this, the cost will be there. The fastest memory will be very expensive. Okay, because it should be built. This memory will be built cell by cell. Okay, so inside a single cell, how many components have been used within a single cell? Single cell matlab you can imagine you can store only one bit, either 0 or 1. Okay, that only you can store. Okay, single cell, the miniature portion of the memory is called cell. Okay, so if you look at any memory, you can split the memory into cells. Okay, one cell is equal to 1 bit. So now you can imagine how small it is. So when the manufacturer create the memory, to create a single cell of any memory, if they spend more amount, that means that is directly proportional to how many components they used in that single cell. Okay, or we can say how much costly materials they use to build a single cell by cell of the memory. So depending on that. So if 1 nanosecond this is the highest speed, high speed memory. So this is a very costlier one, very expensive one. And this is little less expensive than this. And this is less expensive than these two. And this is less expensive than the above 3, like that. Okay. Okay. So what we saw, the top layer consists of registers. So the top layer, I said it is a high speed, capacity is very less small, but very expensive. Okay. So the top layer consists of registers internal to CPU. Here we are talking about the registers which are internal to CPU. Okay. Peripherals may also have registers, but we are not comparing that. We are comparing only the internal registers. The top layer consists of registers that is internal to CPU. They are made up of the same material as the CPU. To make a CPU, what material we use? The same material we used to create the register. So it is very fast. Processor is a very costlier part. Processor is nothing but a chip, students. You know chip, no? So that's a chip. Okay. So that chip is very costly in the entire computing device. Okay. So in using which material we make a chip, processor chip, the same material they use to build the registers. Okay. Hello. So I have to get here. Okay. So registers are made up of the same material as a CPU. So it is very faster one. So there is no delay in accessing the data. Okay. So inside the register, whatever you store, very quickly you can access. You can say it is the speed equal speed of what processor. Access time is equal to the speed of the processor time. Okay. The storage capacity available in this top layer is very less, 1 KB, like that only you saw. Okay. Uh, so now these registers can be directly handled by CPU. Registers can be directly handled by CPU. That's why it is high speed. Next is a cache memory. After registers, the cache memory, which is mostly controlled by hardware. Remember, cache, but there are many types of cache. Okay, even in our browser also we have a browser cache that will buffer whatever page frequently we visit, no, that will be buffered, that will be stored. Okay. So everywhere, if you take the computer, in many places there are cache, but we are talking about the cache. RAM, we can say that's a RAM cache. We are talking about the RAM related cache. Okay. Now this cache is controlled by hardware. Okay. But generally, theoretically, the main memory is divided into the portion of the main memory, we can say. The portion of the main memory is divided into cache lines. Why they are saying this? You may wonder, ma'am, cache, you said cache is different than main memory. But what they are saying here is there is no separate chip, memory chip for cache and main memory. Okay. You can assume in this way there is a single memory chip, a portion of the memory chip used to develop using a different material, and another portion of the same memory um, uh, be used to different material. Okay, you can assume like that. Okay. So here they are saying main memory is divided into cache lines. Okay, because why it is cache lines? Why it's not cache? Because cache may also there are hierarchy inside the cache. Some of the caches are very high speed, some are little less, some are very less. But all the cache lines will be definitely speeder than RAM. Students, can you follow? uh, so cache lines, for example, um, if suppose the 64 bytes, first 64 bytes of RAM, which has the address 0 to 63. So 0 to 63 matlab what? How many addresses? 64 addresses. Okay. So 64 bytes of memory will have 64 number of addresses. Okay. So first 64 addresses will be cache line 0, and in main memory next 64 to, for example, 64 to 127. Okay. 64 to 127 addresses are in cache line 1, and some more other addresses will be in cache line 2. So like this the process, the memory would be. Okay. But don't think always in all the computers the cache will be splitted into different levels. Okay, we are talking about the modern computer. In modern computer, cache is not a single cache, main memory, not a single portion of the main memory. Again, the cache portion will be divided into many layers. Okay, we can say many levels. Okay. In that, cache 0 will be little near to CPU, so it will be the speeder one. Okay, when comparing with the cache 1 and cache 2. And cache 1 would be middle of cache 0 and cache 2, so it will be little far than cache 0 from CPU. So like that it is. So accordingly, the speed will also differ. Cache 0 will have high speed, but of course it is less speed than the register. Okay. Cache 1 will be little slow than cache 0. Cache 2 will be slower than cache 0 and cache 1. Like that it would be. Okay. So why we have to split this into many levels? The cache should be split into many levels. The most heavily used cache lines are kept in a high speed cache located very near to CPU. Okay. So when the program need to read any data from memory, okay, actually CPU will read the data from memory. Okay, then you may ask, ma'am, in between, why? What is the need of cache memory? In main memory, assume that there are some data we used very heavily. Okay, heavily means very frequently we used. Okay, this very frequently matlab what? Within, now I am starting my computer. Okay, my RAM is what enabled. Okay, now when without switching off, I use data, one table I'm using. In that table, one particular record very frequently I am retrieving, and then I am storing that, and I'm changing that. I'm working on frequently in that particular record. So that record will be stored in a cache memory. Okay. So if if CPU while processing, please understand, while any instruction is getting processed by processor need the data, no operands will be stored in the memory. So it will not directly go and look at the main memory. Before looking at the main memory, it will look at the cache. Okay, because the data if the data is there in a cache, quickly it can retrieve, okay, than main memory. Okay, so if the data is there in the cache, when CPU is looking at the data, CPU will not look at. Here the operating system only will do this process. Okay, so when operating system looking at the required data in cache memory, in the cache memory the data is available, that is called cache hit. Hit. Okay, then the operating system will not go and search the same data in the main memory. Okay, from the cache it will take the data and give it to the CPU for processing. Okay, but if the data is not there in the cache, that is called cache miss. Miss. Cache hit, cache miss. Okay, so cache miss happens. So that means the requested data is not there in the cache memory. Then in the next step, in a 3-level cache, next step the CPU will look at in the cache 1. There also, if it is not there, cache 1, cache miss happen. Okay, so now then it will go to next cache line. Okay, if there also it is not there, cache miss will happen, and then at last it will look at in the main memory. Okay, of course in main memory definitely the data will be there. So because already it searched in cache, no, in cache it is not there, so the data is not frequently accessed data, so it will take from the main memory. Okay, it will take it from the main memory and then it will keep it, sometimes it will keep in the cache. Okay, and then it will take an access in the by the processor. Okay, so sometime the data will be there, sometime matlab what, if any new data should be fetched. Okay, cache 1 is not free, but the data should be kept inside the cache 1. So which data is prolonged being there in the cache will be removed, and then to keep the new data. So like that, the frequently or we can say recently accessed data will be there in this different cache lines. Okay. So here you have to remember cache miss and cache hit also. Should I repeat this, students? Is this clear? What is the use of cache? Frequently and recently used data will be saved in a cache memory. Okay. See, you
Yes.
can imagine there is a line. In that line, first CPU, next you can keep register, but it is not next register, it is inside the CPU only, but for easy understanding, okay, you keep first CPU, that means our processor, and then in the second place may register, and then cache 0, and then cache 1, and then cache 2, and then main memory. Okay, so you know that the instruction currently processing instruction data will be stored in the main memory. Okay, so from the main memory, whenever it is a particular data is getting accessed from the main memory, only that particular data will be picked. Okay, and it will be processed by the processor. But when it is picked, okay, it will be stored in the cache, whichever cache is free, cache 0 or cache 1 or cache 2. Okay, so there it will be there, and then the same copy will go to the processor. So when data is getting executed in the processor, there will be a copy of cache also. Okay, there will be one copy of the same thing in a cache also. Okay, so like this, you assume that the cache can hold. We assume here there is a single cache. Assume that the single cache can hold only 10 number of data. Okay, 10 number of data. That is the maximum capacity of the cache memory. Okay, so on today a particular time I'm starting the system. Okay, I access some data. So cache now, initially cache is completely free. Now cache 1 got stored. One of the data uh, stored in the cache, and then second data stored, third data stored, fourth data stored, fifth data, like 10, all the 10 data got stored. Now cache is full. Okay, so when next data, when I retrieve, when the CPU wants, I will go and look at in the cache. Okay, assume that the data is not there in the cache. I will look at in the memory. Okay, yes, in the memory it is there. I will pick up that for processing, but I will store, I have to store that one of the copy in the cache, but the cache is full now. Okay, what I will do, I will apply, I matlab here operating system may apply any of the algorithm. Okay, any algorithm. For example, there are many algorithms, we will be discussing that. Okay, for example, when I'm saying algorithm, you may think what would be the algorithm. For example, the data which came first into the cache, that should be deleted, because now there is no space to keep the new data. No. Okay, so this could be one algorithm. For example, first come, first served. This is the name of the algorithm. Which data came first, that should be deleted whenever the required come, because that is a old data, no, inside the cache. So that could be deleted. This is one of the algorithms. This is one of the algorithms. Remember. Okay. Another algorithm could be in the data, which all the data will not be in the same size. Okay. Because if I store a equal to 20, if I store a equal to 2000, both will not be same. Okay. So every data will be in different size in cache. So you may apply the algorithm, operating system may apply the algorithm. The shortest data should be removed first. So it will compare all the 10 data, which is very small one, that will be removed. Or otherwise the algorithm would be ulta also, which is a very long one, that could be deleted. Okay, so like that's any of the, by following any of the algorithm, the current data will be deleted if only if the cache is full. Okay, no space to store a new data, then only. The same thing is applicable in main memory also. Remember, main memory also, because all these memory are very less in space, no? Okay. So if any data should be deleted, that could be deleted from the main memory also. Okay, by applying any of the algorithm. The applying the algorithm and all will be taken care by our operating system. Okay. Operating system will be designed by following any, it's not any one algorithm, any, it could be more than one combination of algorithm also. Okay. Okay, now this is about the cache memory. About the disk, we will discuss in the next lecture. Okay. Students, so next lecture when you will come, I may ask, what is the use of cache? Why? Yes. That's what I said. RAM, the portion of the RAM will be usually used for CPU cache. Underline CPU cache. Okay. What is level 3? Level 3 cache. That's what I said. Level 0, level 1, level 2. It is depending on the processor. Sometimes it is level 3 also. Okay. Cache lines, the entire cache memory will be splitted into cache lines. Okay. When I'm saying L0, that denotes level 0 cache. L1, level 1 cache. Okay, you have to write L capital letter. Okay. The difference among all these levels are, as I said, speed again, because you are placing the L0 is very close to CPU, but little far from register. Okay. And when you compare L0 and L1, L1 will be little far than L0 for CPU. Okay. So if something is little far, of course, it will take some time, no, to processor to retrieve the data. So that is the this. That is the logic behind this. Okay. 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 Thank you, students. You all can leave.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Students, when you're
Thank you,
coming
ma'am.
for next lecture, you
Thank
have
you,
to
ma'am.
know. Of course, tomorrow is a holiday. Day after tomorrow, I think you have OS lecture. You have to know what is cache memory, what is cache lines, why it is splitted into cache lines, and you have to know the different speed and um, access time and capacity of different layers of hierarchy of memory. Okay, just read and come. Okay, I have to share the book. 1 second.
Excuse me, ma'am.
Yes, I will share the book in the team. Okay, team files. The files folder is there, no? In that I will share. Yes, somebody
Okay,
called
ma'am.
you.
Ma'am, today we will having operating system practicals.
You did not join for the lecture on time, because in the starting of the lecture
Actually, ma'am, I
said
was late. I was late at 5 minutes.
5 minutes. Okay, so students, please don't join lecture for lecture late. Join on time. Then I have to do first 10 minutes only. I will allow you, and then I have to enable the lobby. Okay, so don't make me to do that. Okay, join on time. You don't have operating system practical today. Okay, practical, before starting the practical, I will let you know. Okay. Okay. Thank you, students.
ma'am.
You all can leave. Bye.
Bye.
Bye. Bye. Bye.